All right, everybody, and welcome to the Daily Space Weather Show. We've got more space weather on the way. We'll tell you all about it. Coronal hole high-speed streams, as well as 2 more additional coronal mass ejection impacts. We'll cover it and lots more today at the Smash News Network. Least busted name in news. This is the past 24 hours from the SDO. We normally show 304 plus 193 angstroms. I figured I would do some breaking things down. So this is just 193 angstroms by itself. And here is the 304 angstroms by itself. That is ionized helium. That is ionized iron. So we're going to show some extreme close-ups in the 304 angstroms wavelength today. By the way, we do have a slight uptick in general solar activity here, as well as, again, 2 more coronal mass ejections on the way to Earth. So there's the North Polar region. Lots of large plasma filaments on the Earth-facing portion of the solar disk. Here's the Southern Polar region. And we'll show some close-ups of the active locations. So first, this one in the southeast. And here's a shot of this sunspot in the center portion of the southern hemisphere. And here's an even closer view of that picturesque sunspot group. So we do have kind of a low likelihood of major solar flares actually at the moment. We don't have very magnetically complex sunspot groups. But again, we do have more space weather incoming, so plenty to talk about today at the Smash News Network Least Busted Name in news. And let's talk about supporting the channel. If you'd like to support the channel, become a member of the Smash Team at smashomash.com/Smash Team. Help keep these videos publicly visible, free for all to view. And existent. There's a bronze level, there's a silver level, there's a gold level. Just log in and click posts to see the latest posts for your level. We do send out email alerts. For all of you people out there who have been complaining about not getting notifications from certain web hosting services, yes, certain video hosting services on the internet, you know who we're talking. Lots of people aren't seeing the videos, so we made a solution, but it's up to you to follow that solution. Smashomash.com/Smash Team. Email alerts. That is a paid endorsement of the Smash Team website, smashomash.com/Smash Team. The following are also paid endorsements. Our merch. So we invite you to do the math, because if you want to do something right, do it yourself. Or if you want something done right, do it yourself. Do the math. Here's the equation. 8 equals capital D. Hopefully you don't suck at math too much to understand these videos. So that's got a feature on there that you might be interested in. That's the galactic core right in there. The galactic core, Sagittarius A star, is featured on this Do the Math design. The core of the Milky Way galaxy there, the, quote, supermassive black hole, and, quote, at the core of the galaxy, the radio source, around which many supermassive blue giant stars orbit. Sagittarius A star, do the math. 8 equals capital D is the equation. Continuing right along to another paid endorsement. This one is the Amazon shop. If you don't own an air fryer, why not get one? Modernize your kitchen with the best way to reheat your leftovers. Man, I'll tell you what, leftovers are never like they used to be. Now that we have the GoWise USA 3.7 quart air fryer. That's the exact one that we have. If you want to pay a few cents more, you can get it in plum. Ours is black, and it is an irreplaceable feature on our kitchen. Check out the Amazon shop at amazon.com/shop/smashomash. Also, thanks to our new Twitter followers. If you are new to the channel, make sure you go follow us over on Twitter. We're just approaching 500 followers, and if you're too scared to do social media because you're spooked of censorship, then just throw those fears in the garbage and create a Twitter account x.com/smashomash. Make sure you follow the hashtag NameThatFilament to name filaments after living people and so on. And sharing awesome auroral imagery and other random space stuff. Although I shouldn't probably say the word random because nothing in the universe is random. And here's another non-random thing. Our homepage, smashomash.com. Did you know that we were sent to YouTube prison? Actually, a crack YouTube unit was sent to social media prison for a crime we didn't commit. And we promptly escaped a maximum security social media stockade to the internet underground where we survivors produces a fortune. If you have a problem, if no one else can help, and if you can find the videos, maybe you can hire the Smash team. No, you definitely can. There's all kinds of links. So help out the channel, visit the links, visit the homepage, press like, subscribe, share, comment, etc. And let's get back to the space weather. So there is November 6th and November 7th to date. On the SVO continuum, we have some growth happening right in the center of the northern hemisphere. So right in there, some sunspot growth. Also some sunspot growth up in the northwest. So there's your little uptick in sunspot number over the past 24 hours. Here is colorized magnetogram for November 6th and November 7th to date. And the most magnetically complex sunspot group is the one in the southern hemisphere, right in the Earth-facing zone here, just moving into western longitudes. Next, we'll look at volcanoes, and it looks like a very short list here. Semeru and Sangay are all that are erupting. Interesting. So Semeru is producing a 14,000-foot ash plume over East Java, Indonesia. Sangay in Ecuador exploding flight level 200 over its flight level 200, a 20,000-foot ash plume over Ecuador, and let's get on to earthquakes. So earthquakes are next on the list. There is a delightful 90-day bar graph for you. And these are the quakes of the past 24 that are of 5 or greater magnitude. Papua New Guinea had a 5.2 at 0 dark 53 this morning. 7 minutes until 1 a.m. Universal Time. Also, Ecuador had a 5.1 at 3:33 Universal Time this morning. Then Solomon Islands had a 5.4. That was at 7:30, and then only 17 minutes later, a 5.5 right in the same location. So a perfect example there of a foreshock. And remember, folks, any earthquake can be a foreshock. Then a long lull in 5 and greater magnitude earthquakes until a 5.4 strikes China. And that is extreme western China, just north of India there. That 5.4 was at 1809 Universal Time, and then an aftershock of a 4.8 magnitude, and then right around the same time, within 30 seconds there of that 4.8 in China, a 5.6 at the Mariana Islands. So practically at the same time there, that one was at over 620 kilometers estimated depth, an extremely deep quake in the western Pacific. That 5.6 was at 18:15 Universal Time this afternoon. And that is the quake rundown. So we're going to get back to space, but before we do that, make sure that you press the like button. It is imperative that you press like. If you do not press like, there will be repercussions. Repercussions possibly for your soul. Don't be a freeloader, folks. Press like, even if you're unable to or unwilling to open your cobweb-encrusted wallet and send the Smash team a few bucks per month to keep these videos existent. Press like now, or share, or else I'll get out of your hair with the 10.7 centimeter radio flux, which is now down to 145 solar flux units, and I will now stop talking in a stilted fashion. There's the 1-year graph. 145 is the radio flux number, represented by that black line for the past year, and looks like NOAA's forecasting some geomagnetic unrest late in the day on the 8th. So again, we are expecting also early in the day on the 9th some geomagnetic unrest and a geomagnetic storm late tonight. So space weather will continue, folks. There's a high-speed stream already showing up, and it's quite high here at 660 plus kilometers per second. We'll get to it. First, the last 4 hours of Earth's magnetic moment from space. Whoops. There we go. So there is the magnetohydrodynamic pressure as modeled by the space weather modeling framework. So a significant variation happening there in the solar wind reported data. A sputtering solar wind is what we're showing here. Next, Earth's magnetic moment from the ground for the past 4 hours. And of course, you'll also see variations. These are based on the same model, the University of Michigan Geospace Model, V2.0, otherwise known as the Space Weather Modeling Framework. It takes into account a lot of things: magnetic fields, magnetic field orientation, solar wind density, solar wind speed, electron flux, and lots more. So that's the last 4 hours of Earth's magnetic moment from the ground as we watch this geomagnetic storm slowly subside. So again, there is a coronal hole high-speed stream continuing on here, leaving basically no lull in the action. We have an elevated solar wind speed from a coronal hole high-speed stream. So look at the solar wind next. And this is what's currently going on from the ACE spacecraft located at Lagrangian point 1. Solar wind speed here over 660 kilometers a second. Solar wind density here only about 2.5 protons per cubic centimeter. And as far as the Discover, a much denser signal there at more like 10.5 protons per cubic centimeter for the density. Solar wind velocity here pretty close, around 600 kilometers per second. Next, our GOES magnetometers here have gotten a little bit more level. We're seeing more consistent readings here in the outer portion of Earth's Van Allen belts there. The GOES magnetometers there, the GOES 16 and GOES 18 in their geosynchronous near equatorial orbits. And let's move on to our top view ecliptic plane field plot. So there you go. That's what's going on with the polarity of the heliosphere. And do we have a sector boundary crossing yet? Earth is only a couple of hours from a sector boundary crossing here, so Earth is about to be in a North Pole environment. There's the North Pole. Earth about to leave the South Pole sector of the heliosphere. Next, our line of sight field plot. Here the B field is depicted in blue, polar fields in red and green for south and north respectively, and grayscale for the photosphere magnetism. We'll also show the line of sight ecliptic plane field plot. There you go. North Pole current sheet will certainly be here by tomorrow's daily space weather video, which brings us to coronal holes. What evil lurks in the depths of the dark, dark heart of coronal holes? Well, high-speed solar winds are a thing. So here again, we've got, like yesterday, we've got North Pole coronal holes rotating in here on the east, but the rest are mostly South Pole. So before we continue on, let's take a look at some more imagery of the closest star here. Here is SDO 171 angstroms. We'll zoom in a little bit closer. There's the equatorial view. These are 24-hour videos, once again, from Solar Dynamics Observatory. How about some extreme close-ups? There is that northwestern limb, as we see some active setting regions there. And let's get even closer. There's the full zoom. Some great picturesque imagery there from SDO. So let's get to where we were, back to coronal holes. So here's the coronal hole situation from SDO. There's the still image. So what we've got here are North Pole coronal hole down here. These are south, and all of these are also south. So a short North Pole-oriented sector is coming in. And here's a little closer view of that coronal hole from which we are currently seeing a high-speed wind. Here it is. And let's move to sunspots. Yes, sunspots. So the sunspot number has climbed a little bit since yesterday. Here it is from Royal Observatory of Belgium. Current number here is around 82, looks like, about 82 sunspots. And here's our flare probability and scoreboard. The most likely places for large flares would be the northwestern limb and those two sunspots in the southern hemisphere. So 3480 and 3477 especially are the biggest probability of producing large solar flares, although it's not all that likely. So let's take a look at sunspots. Here we go. There is the SDO magnetogram. And we'll also show 335 angstroms plus the SDO continuum. So again, we do have a little bit of growth in the northwest and also the north central portion. The rest of those sunspot groups largely stable. And next, solar flares and energetic particles. So no spikes in the proton flux. No solar energetic particle events of note. GOES X-ray flux here has dipped since yesterday, so little interesting dip in the little dip in the X-ray flux with an increase in the sunspot number. Current background flux is probably around about an 8.5, a C 8.5 or so. And the average over the past 24 hours is pretty similar to that. Just around a C1 or a B9 class background flux. Here's a 24-hour video, SDO 94 plus 131 angstroms. No major flares of note. Next, a star chart. I want to know what's going on overhead, so I like to use skyandtelescope.org's star chart. It's super convenient. And if you're viewing the early dusk sky, you might see the rising of the largest planet in the solar system, Jupiter. Next, a solar system forecast. There's where things are today. We'll advance this 1 week to new moon. Here's where things will be on the 14th. And let's take a look at CMEs. Right after we look at the astronomy photo of the day. So it's a Martian dust devil, folks. Which I'm not all that excited about it, but there it is. A Martian dust devil. And I guess I'll play that again for you. Why not? Can we go full screen? Well, the answer is yes. So there you go. Oh my God, folks, it's a Martian dust devil. This will have lots of people claiming that that's not actually Mars, that that's Nevada or something. And guess what? I don't care. Remember, folks, never blame a conspiracy on something that is more easily attributed to ignorance and or stupidity. That said, looking at CMEs, here are yesterday's CMEs from the LASCO C2 and George Mason University's computerized analysis. So that's 102 frames from yesterday. And watch yesterday's space weather video if you're concerned about one of those being earthly directed. Here are today's CMEs. One of those was earthly directed. And guess what? There's another one today. So we're expecting more space weather to start arriving sometime late in the day on the 9th. And those are 94 frames from today. Let's bring in the LASCO C3 as well here as we illustrate where the latest coronal mass ejection is coming from. So yeah, another one on the way, folks. And here's what's up with it. So here's a little closer view. And today, late in the morning, is when that CME erupted. That coronal mass ejection does indeed have an earthly directed component. Let me bring this back. Right in there, you see that CME coming out of the east. There is a partial halo component to that that will have another earthly directed coronal mass ejection. So exciting stuff going on. We'll also show stereo A. I haven't looked at this one myself, so discover it with me. Here's stereo A along with its difference imagery on the right, the raw coronagraph on the left. And what do you got, stereo A? There's that CME popping off. So most of the ejecta will miss Earth to the east, but there will be a significant portion likely to strike the third rock from the sun. So there's the difference imagery. You can see it does include a partial halo there. Looks like some relativistic particles showing up associated with that also. None showing up on the GOES proton flux though, so they haven't made it deep enough into the magnetosphere to show up on the GOES. And let's take a look at our custom coronagraphs. So there's that CME. The one coming out of the east is the one that we're talking about. That is likely to provide some additional space weather coming sometime early in the day on the 10th. So 9th and 10th now. More space weather on the way. 2 more coronal mass ejections headed toward Earth. There's a little closer view of that. And the area where that CME came from is right up here in the central northern portion of the closest star. So here you'll be able to see that right in there. That right there, right about there. There it goes. Or I should say, here it comes, because that is yet another earthly directed CME. And let's head to look at filaments. So there's the Big Bear Observatory, and quite a few significant filaments. You could name them after living humans. I don't know. Feel free. Follow the hashtag NameThatFilament over on Twitter, x.com/smashomash. Will you be our 500th follower on Twitter? We may have to organize a prize for our 500th Twitter follower. I guess we'll have to require proof for that. I don't know. Drop me a line if you want to share auroral imagery, by the way. That's the best place to do it, over on Twitter. And let's take a look at filaments from another view here. Also from Big Bear. This one does show prominences as well. Massive solar filaments on the Earth-facing portion of the solar disk. And let's do bonus features. Starting with the GOES 16 SUVI. So what's been happening for the last 3 hours or so is what we're looking at now. And why does it not scroll? Anyway, that's what's going on. Not super exciting here at the moment. Don't expect the lull in activity to continue. We are not yet at solar maximum. So here come bonus features. And the first thing we're talking about is satellite charging hazards. So do we have any, you ask? All right, well, I tell. We do have some satellite charging hazards. Once again, over Southeast Asia. Places like the Philippines and Malaysia and Indonesia. Also Eastern India, China, and Korea. Seeing some surface charging there as low-energy electrons build up on the outside of spacecraft. It could create some communications breakdowns, but likely no damage to the satellites. Next, the GOES electron flux here. The GOES 18 is over warning levels. The GOES 16 here just below warning levels. That's the past 3 days of radiographic measurements from the geosynchronous near-equatorial satellites. There is the 1-year chart of the relativistic electrons. And there is the forecast model. NOAA is expecting an uptick, and I would agree with that forecast represented by the green box. Also, we'll show the layer where it's measured, the F layer. Right about there, at about 300 kilometers of altitude, here is the F layer in its vibrational frequency, and it's calming down as we're getting back to geomagnetically calm conditions. The ionosphere is following suit. So the Earth system here snapping back to static equilibrium rather promptly. Because the magnetosphere is not dying. Civilization is not ending because the magnetosphere is evaporating. It's just utter nonsense by people who don't understand basic physics on YouTube. So anyway, here's the anomalygram. And you'll see a lot of red disappearing off this image. And a lot more blue popping up. It's anomaly in megahertz from a 30-day median. The red represents low-frequency anomalies. The blue represents high-frequency anomalies. And again, like I said, you'll see these subsiding here as the video gets closer and closer to the present time. And here's the latest image, which is 2300 universal time for the ionogram, and there's the anomalygram. We'll also show the global ionosphere nowcast. It depicts radio frequency, maximum usable frequency on the right, and total electron content on the left. A quick global snapshot of what's going on in the ionosphere before we show the total electron content. So here's total electron content. It's free electrons to about 12,500 miles of altitude. Here it is on a global basis. And yes, the data still looks erroneously. Here it is on the North American anomaly from the 10-day average basis. And that looks legit. So there's where you're seeing high and low frequency total electron contents. And we're closing out space weather with the latest intensitygram and magnetogram. So there you go. There's the full disk rockback. There is some rising possibility of a large solar flare up here. Besides that, the most likely place to see a large flare would be down here, followed by these two groups. So 3 different spots where you could see a large solar flare in the coming 24 hours. Make sure you tune into tomorrow's daily space weather video to see that, and let's go wave chasing. We found the world's largest waves. They're south of Greenland here in the North Atlantic. And we've got 37 footers down there. Those are the world's stormiest seas. This imagery depicts surface winds and significant wave height. So there you go. Those are the biggest waves in the world there. Some chilly, chilly weather in the northern Atlantic. And here comes our meteorology segment. We used to separate it and put it in special videos just because people say, hey, make the videos shorter. That'll do a thing. Well, we did. Guess what the thing is that it did? It made our views drop significantly. So apparently people like long videos, regardless of what idiots on YouTube who don't make content or other entities say about it. Apparently there's a lot of crappy content on the platform. So, I mean, what can you say? That's the way the cookie crumbles. Anyway, these are the surface winds for the east. These are the jet streams for the east. These are the jet streams for the central world. What about the surface winds? Well, there you have them. Surface winds of the west looking like this, and the jet streams looking like that. It's like this, that, and this, and Here's the clouds and fog over the Americas. Major cloud nucleation and storms happening across Brazil. We'll show you some more evidence of that. That's what's going on in the Western world. And check it out. Here's a close-up of this rotating low in the North Atlantic. So a great example of a gloomy, nasty day to be seafaring in the Northern Atlantic. A strong counterclockwise rotating low pressure system there to the south-southeast of Greenland. Once again, there is that low pressure. There's the full pressure map. Low pressure systems on either side of North America right now. And next, our weather.gov map. So this is weather.gov, the homepage of the National Weather Service. Check it out if you've got your location lit up on the map. Weather.gov, and here comes some forecasts, starting with the GFS 72-hour pressure and precipitation. Like we said yesterday, some ice coming to New York and New England, also parts of Canada. Going to see some freezing rain. Also some more snow coming to the northern Rockies and the Pacific Northwest. 72-hour GFS pressure and precipitation. We've also got 72-hour GFS temperature anomaly forecast in degrees Celsius. We've also got your lightning mapper, and look at the extreme lightning going across Brazil there. That's pretty berserk. Some extreme lightning sweeping across the majority of the country there. Very strong lightning signals there over South America. And here's a real-time lightning map. Give it a minute. Blitzoltung.org. And there we go. Pretty low on the lightning here at the moment. Only 58 strikes per minute. And we're going to close out this space weather and meteorology video with U.S. Doppler radar. We showed you the 50 state. We'll focus on the lower 48. Here is clouds and fog over the lower 48. And there is water vapor. Clear skies over most of the southern U.S. here at the moment. Here's your recap. Ground-based Doppler radar systems depicting vertical motion in the air column. Things like ice and snow and rain falling from the sky. Next, clouds and fog, space-based satellite systems showing infrared radiation depicting clouds and fog even at nighttime. And there is the water vapor map. That should clear things up for you from your space weather all the way down to your Earth weather. Once again, congratulations on realizing the Smash News Network least busted name in news exists. I'm going back to my bunker because I've become spooked of both space weather and Earth weather because I've been watching a lot of utter crap, bollocks, and nonsense from people who don't understand basic physics on YouTube. So in the meantime, may that solar wind be at your back. And I'm going back to the bunker again. Lots and lots of stupid stuff encourage me to climb in.